this video, we're going to continue our set of review problems. So think of these as test problems or homework problems on the stuff that's in this playlist on derivative concepts. In our last video, we ended by trying to take a formula or a table for a function and estimate or approximate the derivative. We want to do the same thing now given a graph. So here's a graph of some function. Let's say y equals f of x. And we want to use this to approximate f prime at 2. So go ahead, you should be able to do this at this point. Press pause now. Okay, so hopefully you've worked this out. If you haven't, press pause and work it out. And now we're back. We're going to work this. Now I already have some dots on here. Those probably shouldn't have been there to begin with. But the point of interest is right here. This is 2 comma f of 2. Looks like about 2 comma, let's see, that's negative, maybe around negative 14 or so. And then we have these 2 points here on either side. So what I went was half of a grid line either direction. You could go a full grid line either direction, or maybe a half of a grid line each direction. So I went about half of a grid line each direction, and we're going to use the symmetric difference quotient. Now let's see here. The grid lines, let's see, that's 1, that's 2, so there's a half for a grid line. So we're using an h of 1/4, a fourth to the right, a fourth to the left, still gives you a delta x of 2h, which is a half, the same as the grid line spacing. So we know the delta x is exactly half. We need to estimate these y values. So we're using x is 1.75 here, and x is 2.25. So again, for delta x, that's 2.25 minus 1.75 is 0.5. Now we just got to find the y values. So I estimate this one here to be about negative 17. So this is negative 10, negative 20. There's negative 15. So if you break this up into 5 equal pieces, that looks like about 2 of them. So that's about negative 17. And that one looks like it's right on a grid line. So that looks like that horizontal grid line. That looks like that's right at negative 10. So if we use those numbers for our y values, then in fact what do we get? We get negative 10 minus negative 17 is 7 going up. So that is a positive change in the vertically and a positive change horizontally of 2.25 minus 1.75 is 0.5. So from this point here on the left to the one on the right, we're going to the right 0.5 and up 7. That works out to be 14. And so then the slope of the secant line between those 2 points at least is approximately 14, and that's very close to the slope of the tangent line right there at the point in the middle where we want to be. So the derivative at 2 is approximately 14. Actually, on this particular graph, the derivative is actually 14. So hopefully you were able to get something pretty close to that. You might have been plus or minus that just a little bit because of estimating these y's, but you should have gotten something very close to 14. Now this next one is a different kind of problem here, but it's very similar. Here we have a function, maybe a different function, but we have some kind of function here. And we want to put these things in order from smallest to largest, or from least to greatest. Okay? So we have f of negative 6, f prime of 1, f prime of negative 1, f prime of 4, f prime of negative 2, and f prime of negative 5. Now notice all 6 of those things are just numbers. Well, they're not just numbers. They're numbers with a meaning, but they're numbers. And so we can take those numbers and order them like we would on a number line from least to greatest. Okay, maybe instead of smallest to largest, I'll say least to greatest. Okay, so see if you can do that now. Come back when you think you have your answers there. Press pause now. Okay, well, let's see what we have here. Well, first of all, like they used to do on Sesame Street, one of these things is not like the others. This first one, f of negative 6, is very different from all the rest. All the rest are values on the derivative function. This is actually a value on the original function. So the first one, f of negative 6, is actually a y value here on this function which looks to be a little below that, so it's a negative 7 point something, maybe negative 7.1 or something like that. The rest of these guys are values of the derivative, so they're slopes of the tangent lines. So we're going to find B, C, D, E, and F. We would find them the way we just did this last problem up here. Now, we can actually get numbers for each of these and then just put the numbers in order, but we may be able to put these in order without even getting the numbers on it. So let's just kind of get over some rough ideas. F prime at positive 1 is right here. That's very close to 0. Maybe just a teeny bit negative, but almost at 0 because it's almost at the minimum right there. So that's just about 0 there. F prime at negative 1 here is definitely a negative number. So far we know that that's less than this one at 1. F prime at 4, that's up here, so that's a positive number. Okay, so we definitely have those in order. F prime at negative 1, then F prime at 1, then F prime at 4. F prime at negative 2, well, that's also a negative number. Okay, so let's compare the F prime at negative 2 and F prime at 1, negative 1. Well, it looks like that's all on a concave down piece. When you're on a concave down piece, the slopes are decreasing. So it looks like negative 1 will be the least, the most steep, the further away from 0 on a number line. So that's going to be the least of the bunch. I think that's the least of the whole bunch. F prime at negative 5 is over here, and that's a positive slope. So definitely F prime at negative 2 is the least. Then where was the other negative one? F prime at negative 1. Then the one that was basically 0 or close to it, F prime at 1. And then we have the positive ones. So let's see if we can get those in order. F prime at negative 2, F prime at negative 5, and then, oh, wait a minute, F of negative 6 is a negative number, negative 7. So we'd have to look at this slope here and see if it was this one at negative 1, see if it's more or less than negative 7. So to put the F6 in the order here. Okay, well, I think, let's see, if we go to the right half and left a half, if you look, we're dropping, so it's a delta x of 1, we're dropping a little bit more than 1, so it's negative 1 point something there. At negative 2, the slope is even less than it's more than that, closer to 0, but still negative. And nowhere near negative 7. So the least is F of negative 6, then F of negative 1, then F of negative 2, then F of 1. Sorry, some of those should have said primes. Let's say that again. F of negative 6, then F prime at negative 1, then F prime at negative 2, then F prime at 1. All right, so what does that leave us for the positive parts? The only ones of these that are positive are F prime at 4, which is a slope right here, and F prime at negative 5, which is a slope here. I think we can see that this is steeper over here on this side than it is here. If we wanted to estimate this, we go to the left and right one grid line. We see we're here, and we're going up 1. Vertically, they're spaced 1. So that's 1, 2, 3, 4, 5, 6. This is in the vicinity 6 or thereabouts. So slope of around 6 here. Whereas if we do F prime at negative 5, we go the right and left one grid line. Look how much we're going up. Well, it's about a half, 1.5, 2.5, maybe 3.5. So the slope here is more like 3.5. So definitely bigger here. So let's see how that. Let's see if I've got those in this right order. So that was F of negative 6, F prime at negative 1. Let's see if I've got F prime at negative 6, F prime at negative 1, F prime at, no, that's not right. F prime at, okay, I gotta fix something here. So F of negative 6 is the least. That's about negative 7.1 or 2. Okay, that's good. Okay, then next should be F prime at negative 1. And we said that's negative 1 point something. Negative 1.3. Okay, so that's next. This one's in the wrong place. This one should say negative 1 here. okay, which is C. So f prime at -1, then at -2. So this should be at f prime at -1. F prime at -2 is about -1, so that's a little higher. So -2 is less, then -1. There we go. Get that right order. Then f prime at 1 was very close to 0. Real close to 0. And then f prime at -5 was actually positive. It was about 3.5, and that's what we said a while ago. And then f prime at 4 was the most, and we said it was 6 point something there, I think we did. Okay. 1, 2, 3, 4, 5, 6, and a little bit more, about 6.3. In fact, 6.2. In fact, I think with the formula that I had whenever I made this out, I worked out using the formula. I've got these to 1 decimal place, and these are all accurate numbers here to 1 decimal place. And we were able to get pretty much that accurate just by looking at the graphs. And so that puts them in that order. Let's make sure these are in the right order. So then A, so it's A, then A, C, E, B, A, C, E, B, F, A, C, B, E, F, D. Yes, that's the correct order. D. The last one. Okay? Now, like I showed you, we can use symmetric difference quotients to approximate this. If we did this for a number of places, or if we used the formula and did it at even more places, we could compute and plot those x and y values. So for example, we could plot -6, -7.2, and 1, 0, and -1, -1.3, and 4, 6, 6.2, and so forth. And if we graphed a lot more of those, we would end up with this shape right here, which is the actual derivative function. And here you can see the values of the derivative to several decimal places, at least 2 or 3 decimal places here, as y2. And of course the original one, you can see the functions is I guess 4 decimal places there for these particular x values. So that's what the graph looks like. By the way, while we've got this here, let's point out some characteristics that are interesting. So the blue is the original function f of x, the red is the function f prime of x. Notice that when the derivative is above the x-axis, that means it has positive y values. Looks like it's happening from about 0 to about 3-ish. Okay, maybe just to the left of -3, I should say. Then that's when the original function is increasing. So positive derivative means positive slopes, which means the original function is increasing. So positive values of the derivative means the graph of the derivative is above the x-axis. It means the graph of the original function has a positive slope and increasing. That's going to happen over here. Happens over here again, looks to the right of about 1 or so. To the right of that, we have this function is increasing as well. In between, say in between about approximately -3 and -1, then the derivative has negative values, and so the original function is decreasing there. It has negative slopes. The tangent lines have negative slope. And of course, where the derivative is 0, about -3 and -1 roughly, that's when the original function, wherever exactly that happens, that's where the original function is going to have a horizontal tangent line. And since it actually changes from increasing to decreasing right there at about -3, that's where the maximum is going to occur. So that's a local maximum. And you have a local minimum here where the derivative is equal to 0. So where the derivative crosses the x-axis, the same x, is going to give us a horizontal tangent line there, and it's going to be a local minimum. Okay? Come back for the next video and we'll do some more problems.